Now my next step is to put a square on it. Oh, good. Hey drivers, we're gonna jump back into the boring bar and figure out how to do a thrust cut. There's a bit of an issue though. I'm pretty sure that the old boring bar that I bought years ago is missing at least one part. Let me show you. When you push on the clutch, it pushes against this bearing, and that puts pressure on this little lip here in a soft magnesium case. Over time, that gets pounded out and the bearing will scoot back and forth, and that's really, really bad. What we want is for this to be a nice snug fit on that flange. So what do? Well, you trim this down to a really specific size and then put an oversized bearing in place. If you look really close at these two bearings, the difference is right here. That's all standard. But this lip over here on this other bearing is thicker. That takes up the space that we'll end up cutting out of the thrust area on the case. So what I need to do is to make a bit that will actually cut this, and then come up with a way to set up my boring bar, kind of reverse engineering however they did it back in the day, so that I can make a precise thrust cut. Now just looking at the problem, I think what I would like to do is also be able to do a cleanup cut on this side. When I look at the bearings, the ones that I've seen don't have any way to compensate for a cut back there. So I want to do that real sparingly, but just a cleanup cut so we're back down to fresh metal and do whatever cutting we're going to do over here. There's a possible problem. I think there's some room here to make it work, but here's the problem is the dowel pin holes, they need to line up. If we do this cleanup cut, it's going to have the effect of moving the bearing forward by however much we cut it. And so you see how that's going to affect how that dowel pin lines up. But here's the thing, look at the difference in the sizes of those holes. We're looking at the one right in the bottom of the saddle here. That's a snug fit with the dowel, but this is not. In fact, this hole is about 1 millimeter larger in diameter than the dowel pin itself. So there is some wiggle room here. Assuming the dowel pin is right in the middle of the hole on the bearing, we would have 20 thousandths of clearance all the way around. I do not think we're going to be taking that big of a cleanup cut on this side of the bearing. I'm thinking a few thousandths should do it. And that's really, I mean, the benefit of it is really just to have a nice square surface here. It shouldn't be in terrible shape to begin with, because all of the pressure of the thrust surface comes over here with the operation of the clutch. So I think we're going to be okay, but definitely something worth checking as we go through the procedure. I'm also curious about the crazy idea of chucking this thing in the lathe and trimming down that lip. That way I don't have to go a full 40 thousandths of an inch. Like the first oversize, there it is. You see how it says FL-1? That is a 1 millimeter oversize on this flange. And I think a lot of times you don't need to do that. So if I was able to chuck one of these in the lathe and trim it down, I could hone in on just enough of a thrust cut for my case. Seems like good practice anyway. Let me set up the bar so you can see how far I've gotten. For starters, I had to make a bit. This is just high-speed steel, but I made some grinds on a small bench grinder so that I have the cutting angle here, or whatever it's called. I got a little bit of relief back here. I made it long enough to cut the entire opening that is reserved there for the flange. So this, I think, is gonna be good. So for that cleanup cut I was talking about, I'll mount the cutter in here. We'll snug the cutter down about right here on the bar. We'll need the bushing in place. Of course, we'll do all of this with the case torqued down. This other nose bushing in place. And I think we'll bottom it out right there on the existing thrust. Like, this is just barely shaving a little bit of magnesium right now on this practice case. Watch this, this is crazy. This is some of the magnesium that came off of that. It's so thin and so fine with this cutting bit that you can just wipe it away like it's greasy. It just smudges away. That's how soft that stuff is and how little of it we're shaving off. But at any rate, what I'm going to want to do is bottom out the cutter bit, and then I have this collar here, and it looks to be precision. to me. So I can take this and put it on the end of the shaft down there and use a feeler gauge to set the depth of cut, right? So if this cutter is all the way up against the surface and I put a feeler gauge in here and tighten things down, then that's going to be my depth of cut. So I can sneak up on it. Problem is, this bushing doesn't work back here. For starters, the bolt collides with the bushing, and I could just put a shorter bolt in there and that would work, but there's no great way to get in there to this surface and take my measurement. So I think I need a collar. I need a sleeve to bottom out against this area. It looks like the one that goes with this kit was about 2 inches in diameter, right? Way bigger than this thing. So I need like a 2-inch diameter collar that comes all the way out to about right here, where I can easily put this collar up against it, do the same thing with the feeler gauges, and set my depth of cut that way for the real thrust cut that we'll be making. I don't know where to get such a thing, but I do have a lathe and a desire to learn how to use it. I'm gonna have to figure out how to do this. So we're gonna do some turning, some facing, and some boring. That's the part that I'm most nervous about, to see if we can build a collar for this Portatool setup, and then see if our ideas work about cutting the thrust. See, this is the learning process I was talking about. Here we go. I think I have it set up, so I'm gonna take this slow and see if I can face off the end of this solid bar. The idea is to use this to make the collar. This is about 2.5 inches wide, and it's solid. So we'll turn it down to 2 inches, bore it, and part it. And I'm not sure about any of those. So we'll take it slow and I'll learn as I go. I just made what I think is the last pass on this hole here. You know, this thing's gonna be a collar for this boring bar, so I need it to fit, right? Let's try it out. Cool. I could feel I was compressing the air when I plunged that in there. Yeah, so that's cool. That's gonna work for us. Going to take the first of many cuts. We'll be turning this down to 2 inches. I'm going to come to about 1.5 inches from the end because we'll end up parting it right about here at 1.25 inches. I think that's an okay surface finish. I'll go with that. Things are going well, so I'm getting a little bit more brave with all of this. We're just taking deeper cuts and going a little faster. What you doing? Okay, this is starting to look like a part. I did put a little chamfer here, and we're down to our 2-inch dimension. Now I need to figure out how to part this thing. I sure hope I don't destroy it. I think we're in good shape. Now my next step is to put a square on it. Oh, good. and make sure that the faces are square. That's going to be important in terms of accuracy. Otherwise, depending on where this is rotated around the bar, I'll get different measurements when I'm putting the feeler gauge in there. Let's take a look at those things. We're trying some ideas out here. We're trying out the whole collar and all that, but also this homemade bit. Is this even gonna work? We'll see. I want to see how it feels using the hand crank also, and what different depths of cut feel like. Case is torqued together. Sprayed a little bit of WD-40 there on the surface. We're gonna move the cutter all the way up. Now we'll mess with the collars here on the nose. I'm gonna start with a really light cut here. This is 1.6 thousandths of an inch. Yeah, I can feel it applying to just a portion. I've found a little bit of an issue up here. This nose bushing here is not in perfectly square. It doesn't ever seem to go in perfectly square. Same thing with the other bushing. The biggest part of that is because there's slop in its bore, so it gives it room to cant just a little bit. So there's another issue related to the wear that is on this tool. Let's set up one more cut and we'll look at one other thing that's come to light. Okay, another super light cut. Again, just a sliver. I've gone ahead and attached this hand crank, and I think this is an important part of applying even pressure. So if I just apply pressure down here, nice and even like, while cranking from this end, I think I'm going to avoid some of the chatter that I was experiencing. Let's try that. Well, we could see that we made a cut. I see some blemishes on it here and there. We'll fully take the case apart here in a little bit and do some measurements to see how we did. But at least we're cutting the thrust mostly as intended, and it seems to be relatively controlled. Let's set up for the actual thrust cut. So underneath the bushing is the cutter. I took it off and turned it around so the cutting edge is facing this direction now. We'll throw our collar on here. May be able to do all of this from this side. Tiny little cut again. Pretty easy doing all this on the same side here. It's not as much of a juggling act. Well, that felt like I had hoped. That was just one cut and it quit. We must be doing something a little better over here. Let's do another one. Ultimately, what I would like to do is set up these thrust cuts and perform them as cleanup cuts and stop there at whatever measurement that is, and then prepare a set of oversized bearings for that thrust. All right, let's take it apart, see what it looks like. And it went well. I think we've got a good clean cut here. Maybe I could go a little deeper, but it is square and the dimension is the same all the way around both sides. Messed around with the cleanup cut a little bit, and I didn't think I was doing that much, but as it turned out, I used up all of the slop that we've observed in the size of this dowel hole here in the bearing. So it fit, but I don't think I could have gone much further. So that's definitely something that I'll want to be really careful of and weigh on a case-by-case basis, no pun intended, whether it's even worth trying. But I'm happy with this. The next step is to see if I can cut to a dimension. But before we can do that, we'll have to fix these worn out old bushings. So check out this video here to find out how we do it. And we might even set ourselves up for another attempt at line boring one of these old VW cases. We'll see you in the next video.